So in this first slide, we're going to look at gram to mole and mole to gram. These top two, when it's saying mole to gram, that means you start with the number of moles to find out how many grams that would make of a substance. So for instance, number 3 here on the side, hydrogen cyanide is a poisonous gas with the formula of HCN. What is the mass? So when it asks what is the mass, that means you are trying to find the number of grams. So our answer will be in grams of HCN. What is the mass of 5 moles of hydrogen cyanide? So the first box, you put your given. So you're given 5 moles and you want to find out how many grams that is. So to cancel out moles, to get to grams, you need to put moles on the bottom. So what that does, moles will cancel moles and you'll be left with grams. So for every 1 mole, you have how many grams? HCN. So for hydrogen, we have a mass of 1.01. For carbon, we have 12.01. And for nitrogen, we have 14.01 grams. And you can find these on our periodic table. So for carbon, 12.01, nitrogen, 14.01, and hydrogen, 1.01. We are using the atomic masses from the periodic table to help us find those out. So our total mass for HCN is going to be 27.03. grams. So when we do our math, we can almost pretend that there's an X in between here, like a multiplication. So what you do is you multiply the top and divide by the bottom. So in this case, we have 5 times 27.03 divided by 1. So what that's going to give us for number 3 here is our final answer. 5 times 27.03 is 135.1. Divided by 1 would still give us the same answer. So it's going to be our answer for number 3 in grams of hydrogen cyanide. So this is going from mole to gram. On this bottom one here, we have going from grams to moles. So propane, C3H8, how many moles of propane are in 11 grams of propane? So when it says how many moles, we're trying to find moles of C3H8. Our given is 11 grams, so we're going to plug in 11 grams of propane in our first box. In the bottom one, this is where we use our periodic table. So this is what is given, this is what we're trying to find, and this is what we use our periodic table for grams. So C3, so carbon has a mass of 12.01. There are 3 carbons, plus there are going to be 8 hydrogens with a mass of 1.01. So our total mass for propane is 44.11 grams is what we're using this white box. And we don't usually use this white box. I'm just using it so you can see where this came from for the molar mass. For every molar mass, that is equal to 1 mole of that substance. So what we're going to do is we're going to pretend that there's a little multiplication here in the middle. We're going to cancel out our grams. And we're going to be left with moles in the end. So we're going to do multiply and then divide. Multiply the top, 11 times 1, that is 11, divided by 44.11. So you have 11 times 1, that's going to equal 11. You're going to divide it by the bottom to get your final answer. So our final answer for number 4 is going to be 0.25 moles of methane. On our second slide, there's a little bit harder ones that involve going to molecules. So for number 4 here, these just have an extra step. So we want to know how many molecules are in 19 grams of carbon disulfide. So we're trying to find molecules of CS2 is what we're trying to find. We're starting with our given, which is 19 grams of CS2. That's our given. So in order to cancel the grams here on top, we need to put grams on bottom. This is where our periodic table comes in. So carbon is 12.01, and there's 1 carbon, plus 2 sulfur. And our sulfur, if we go to our periodic table, is 32.07. And some might say 0.6, and that's okay. Either one works. So our mass for the periodic table for our carbon disulfide is going to be 76.14, or 15, sorry, with this extra 1 here. 76.15 grams of CS2. And we'll make this a little smaller so we have some space. So we went from grams to grams. Those are canceled. For the molar mass, that is always equal to 1 mole of that substance. So 1 mole of carbon disulfide is equal to 76.15 grams of carbon disulfide. For every 1 mole of CS2, this is where Avogadro's number comes into play. That equals 6.02 times 10 to the 23rd molecules. So doing this takes a little bit more math. It's still the same, multiply the top, divide by the bottom. There's just an extra step over here. So 19 times 1, 19, divided by 76. So we're going to go to our calculator here. So we have 19 times 1, that's step 1, is 19. Then we need to divide it by, we'll make it equals, 19 divided by, go back here, 76.15. So 19 times 1, divide it here. That equals, that is not right. So 19 divided by 76.15 is equal to 0.25. So if we were to stop there, that would say 0.25 moles, but we're trying to find molecules. So then we need to multiply that 0.25 by our 6.02 times 10 to the 23rd, and then divide by 1. The 1 won't make much of a difference since it's on the bottom here. So if we multiply, so we have 0.25 times our Avogadro's number. So I put in parentheses 6.02 times 10. You hit the AB here to get your exponent, 23, and you add your other parentheses. That's how you multiply it out. So our final answer we get here on the right side, 1.505, so we'd round up, 1.51 times 10 to the 23rd. So we'll go back, and our final answer here is 1.51 times 10, not a question mark, control period to the 23rd molecules of carbon disulfide. The same thing happens up here on the top for number 1. So you're given 200 grams. You still cancel. So if you do sodium hydroxide, the mass is 40. So our grams would cancel. For every 1 mole, that's equal to 40 grams. To cancel moles, 1 to 1. And you're left with molecules on top. So this is your final thing you're trying to find, is the molecules of sodium hydroxide. you would do the same math. So 200 times 1 is 200. Divided by 40 is going to give us 5 times Avogadro's number and divided by 1. So if we were to do, we'll clear this. If we have 200 divided by 40, that gives us our 5. So 5 times Avogadro's number. 6.02 times 10 to the 23rd. And then we add our other parentheses. And our final answer is 3.01 times 10 to the 24th. And we'll go add our answer, and we need to make sure it says molecules of sodium hydroxide. So make sure I get it right, 01 times 10 to the 23rd molecules of sodium hydroxide. One last one we can practice here at the top, going from grams to moles. So you're given 68 grams for number 3. To cancel grams, we need to find out what the mass is. So the mass of nitrogen is 14.01. There's 1 nitrogen. There are 3 hydrogens, so we do 3 times the mass of hydrogen. So 17.04 is the mass of ammonia for 1 mole. So 1 mole of ammonia weighs 17.01 grams. What we do is we multiply the top, divide the bottom. So 68 times 1 is 68, divided by 17.04. So our answer for this will be either 3.99, or you can round up to 4 moles of ammonia.